In this video, we will allocate and attach a UStaticMesh component in C++. But before we do that, I will start off by creating a blueprint that derives from the very interesting actor. As we've seen, one way of doing this is we can navigate to that C++ classes folder and then right-click on the class, and then we can select to create a blueprint class based on that. I will name the new blueprint class BP_very interesting actor. Choose the blueprints folder for the target path and click create blueprint class. The content browser pops up like this. I will click to close that off. We need to get used to this workflow since we will typically create blueprint classes that derive from our C++ classes. That makes it easy for the artist or designer to configure the class within the editor, set the meshes for the static mesh components, assign materials, and so forth, instead of us hard-coding that on the C++ side. In the actor component hierarchy, we have this root that we have set up in the previous lecture, the using component. If I now drag in an instance of the blueprint, notice we don't have a visual representation. Of course, the handles show up with that selected in the outliner and in the level, but if the actor is not selected, then it is not that easy to spot. Now, many actors use a billboard component, such as the lights, for example. Just to demonstrate, I will add a billboard component to our actor. A billboard is a camera-facing sprite, basically an image or a texture. You can modify the sprite that shows up in the details panel if you want, but I will leave that as is. Of course, we can also allocate this component in C++ if we want, but I'll leave that to you as an exercise if you want to do that. Notice that as I move or rotate around, that sprite faces the camera. This makes it easier to see our actor when we don't have it selected and the handles don't show up, and of course if you don't have a static mesh component, for example. Now, where is this useful? Well, as I mentioned, it is used for lights, and it may also be useful if you have some actor that you use as a spawn point for other actors, since those may not necessarily have a static mesh component for a visual representation, just some point where you want to spawn stuff from. So we can add a static mesh component to our class in C++. I will delete those instances for now. To demonstrate, I will open Visual Studio and navigate to the interface file of our very interesting actor. I will declare a pointer to a UStaticMesh component, which I will name mesh. For an exercise, I want you to allocate the component as we have done for the root using component. Okay, let's allocate that component. Again, we do not use new to allocate in Unreal. We use this helper, create default subobject, and for the type argument, that is the type of object that we want to allocate on the heap, we pass in UStaticMeshComponent. I will give that some name. I'll use mesh for this component. This is just an example, of course. You will name these appropriately depending on what the purpose is for the actor and for the component. As I've demonstrated, the include for the UStaticMeshComponent is components/staticmeshcomponent.h, but as with the using component, we don't need to include that, so I will comment that out. Back in the header file, I'd like to demonstrate that you actually also do not have to forward declare these types, since as I mentioned, they come in through the header includes, so we can remove those class keywords. I'm demonstrating these includes and where to find them and so forth because Epic often changes things, and it may be that in a future release that does not come in included, so in that case you will have to include that explicitly, or in the case where you have some IntelliSense problems, for example, then you may also want to include the header that is in the source files. Back in the constructor, remember that we give our components a name by using the text macro and passing in that string. I'd like to give a quick example of where that name is useful. I will navigate to the Unreal Engine documentation, and we have this uClass function getDefaultSubObject by name. In the syntax section, we can see that this function returns a pointer to a uObject, and we can pass in an ifName to find. So with this, we can pass in the name of a subobject that we would like to find, and this function will then return the object with that name. So it's useful in many ways, not just for the visual representation in blueprints. That is also why the name should be unique. If you pass in the name root for both of these components, for example, then you'll get an error. Back in the editor, I will drag in an instance of our very interesting actor blueprint. Notice that with the instance selected, the mesh component does not seem properly attached to anything in the details. In the blueprint editor it seems fine, however, but it's best that we explicitly define what the component is attached to. Before we continue, I'd like to summarize how component attachment is going to work. So how do we set up component attachment in C++? I've demonstrated how we can assign to or set the root component, but we can also attach other using components to form a actor component hierarchy. We can use the function SetupAttachment on a using component to attach that component to the argument that is an existing using component. It is typically used in the constructor of the actor that owns the component, and when dealing with components that have not been registered yet. So what does it mean to register a component? Registration is not that important for this module since we'll be doing the allocation and attachment within the constructors, so I may reiterate this in the next module. But in order for an actor component to update each frame and affect the scene, the engine must register the component. This happens automatically for components created as subobjects of an A actor when the actor is instantiated, or in other words when it spawns. We can also do manual registration for components created during play, and we can also manually unregister components, but I will leave that for a future discussion. We don't need to worry about that for this module. For now, all we are concerned with is how we can do the attachment. In this example, I have some pointer to a using component named myCoolSceneComponent. From that pointer, we do SetupAttachment, and we pass in a root component, so whatever the root component is, we want to attach myCoolSceneComponent to that. Back in the constructor, let's attach our mesh component to whatever is currently the root component. From our mesh pointer, we will do SetupAttachment. We can pass in the root component like this, or we can use the function getRootComponent to return whatever this actor's root component is. I will comment this line out and build and run. Back in the blueprint editor, with our very interesting actor blueprint opened up, I will select the mesh component, and notice we don't have a mesh nor a material attached. Go back to our level, frame up on that instance, and the same thing here. We don't have a mesh and we don't have a material attached, so we could modify that on a per instance basis, or we can assign a default static mesh and a material in the blueprint class. With the mesh component selected, we can click here to select the static mesh to assign. These ones may not show up for you, they are from the engine assets. We can click this cog, and then we have this show engine content that we can uncheck if we do not want those assets, those static meshes, to show up. These cube meshes show up since I have filtered for cube, but notice here we have some more to choose from. Those are part of the first-person shooter template that we've started off with. I'll actually select the blue one, SM_chamfer cube. Compile and save. Back in the level editor, each instance of the blueprint will now have that static mesh and its associated material assigned. At this point, you may wonder whether it is possible to assign a static mesh to the static mesh component in C++, since currently we are assigning that in the editor, that is using the visual tools in the blueprint editor, or in the details panel when we have an instance selected. And yes, we can actually assign that in C++, but I'll demonstrate how to do that in an upcoming lecture. When working with the components in the actor component hierarchy, that is when you have an instance selected in the level, maybe you want to make some changes on a per instance basis, change the material, change the mesh for example. Then remember, when you want to delete the actor from the scene, make sure to have self selected and not one of the other components. Otherwise the actor may not get destroyed, and that could get confusing. With self selected, that top part in the tree, you can press the delete key to delete. Of course, we can also delete from the context menu in the viewport or in the outliner. For now I will close off the editor. Back in Visual Studio, remember I mentioned that we have the root component property. At some point you may think, why don't we simply allocate and assign to that directly instead of declaring another pointer, as I have done here with the root pointer, or with the mesh pointer if we have a static mesh component that we want to set as the root component. With the current setup, we could also set the category of those pointers, so the root property for example, or the mesh property to setup, or whatever feels appropriate. It is also often the case that you find yourself declaring an additional pointer property later anyway. In the case we have a more dynamic actor component hierarchy, where components can change their parent during gameplay. It is best to specify the root component if you want to attach to that explicitly, since if we want to change our component tree and make something else the root, whatever previous component we were attached to may no longer be set as the root component. Also taking readability into consideration, since the reader can more easily understand the setup by looking at the header and the source files. We typically look at the header files first, right? It is not such a big deal if you have a USIN component as the root component, but you may decide to have a UStaticMeshComponent as the root, in which case how do you invoke functions on that? I will discuss casting later, but in that case you will have to cast, since those functions will not be available from root component, as that is a USIN component. So in that case, with an additional pointer to a UStaticMeshComponent, as we have here with the mesh pointer, you avoid having to cast. So for many reasons, from my experience working with the engine, it is best to develop the habit of setting up the additional pointer and to not use the root component directly for the component allocation. Back in the constructor for our very interesting actor, I mentioned we can assign to the root component using this syntax right here. We assign this pointer, whatever that points at, we assign that to the root component. We can use this setRoot component. Now the benefits of the setRoot component, if I right click on that and I pick definition, is that it does some checks and it actually returns a boolean, so we can do a check to see if that is successful, whether the setRoot component is successful. So with this you can start to think about certain checks that you want to do to make sure that the assignment is actually successful. And with this, only components owned by this actor can be used as its root component, so that is one useful check that you can do. Alright, and this is going to return true or false. I'm still in the habit of using this sort of syntax, but it may be best to use this function right here, setRootComponent, alright? So in future lectures you may see me use this syntax, where I simply use the assignment, but you may want to get into the habit of using this function, because again it does some additional checks for you. Just a few more demonstrations to end off this lecture. Getting back to the component names, I mentioned those must be unique. For example, let's say later on during development, we decide to make the mesh the root, so whatever mesh is pointing at, and so we change the name of both of these components to root now, like this. Maybe you forget to change the name of the other component or something like that. With the editor closed, I can build, that is Ctrl B, just to check if I get any errors. We actually get a success and no errors. So with this I may build and run. Again we get no errors. The editor loads, but now we get this crash and the error message is difficult to digest. But here we can see root already exists for the very interesting actor. I will click close without sending and undo those changes. Again we want those names to be unique. Build and run. Back in the blueprint editor, with our very interesting actor blueprint opened up, I'd like to draw your attention to a couple of things. The root and mesh components are now configured and attached in C++, right? And this blueprint class inherits from that C++ class where those are configured. Remember we added this billboard component in the blueprint previously. In the previous lectures I have demonstrated that we can drag and drop to set a component as the root or to set up parent-child relationships. If I click and drag on that billboard component and attempt to make that the root component, we get this error. The root component in this blueprint is inherited and cannot be replaced. However, we can attach that to the mesh component to set the mesh as the parent component for the billboard. Now if I drag the billboard over the root, we only get the option to drop here to attach the billboard to the root. Remember, in previous examples we had the option to set or to attach. Here we can only attach. Keep these things in mind as you set up your inheritance hierarchy. If you want to allow the artist or designer the ability to attach however they want, then you may need to rethink things and not assign in C++, but to do the component configuration in blueprints instead. We don't need that billboard component anymore, so I will delete that. Just press delete. One more thing, notice we have these shortcuts to the right of these components to edit in C++. You may have to expand the panel a bit to see some of those shortcuts. For example, I will close off Visual Studio and then I will click on one of those shortcuts to edit in C++. And as expected, that will now load the solution. Also remember you can get to the parent class by clicking here, where it says parent. That will also open up the solution and the project. If that is not open in your IDE, Finally, I will minimize the editor, so I will keep that open. And remember I mentioned that we can build by pressing Ctrl B, that is to check for errors as we are developing. Let's make a quick change here. I will rename this component to Mesh Component. Now with the editor still open, if I build, so Ctrl B, we actually get an error. We could do this with Unreal Engine 4 with the hot reload system, but things have changed a bit with the new engine and with the new live coding system. We get this error, unable to build while live coding is active. Exit the editor or press Ctrl Alt F11 if iterating on code in the editor. Again, with the editor closed, we can build just fine, Ctrl B. As I mentioned in a previous lecture, we can actually turn off live coding, and then the older hot reload system will be used instead. That is under Edit, Editor Preferences as demonstrated previously. I will disable live coding. Now with the editor open, when we make some changes and then Ctrl B to build, the older live coding system is now enabled and that works fine. This may change in the future, but at time of recording, the system defaults back to the hot reload system. That is when live coding is disabled. I'm just demonstrating this out of interest. I will make sure to enable live coding again. And that is going to wrap up this lecture.